For homework assignment number 12, you are asked to do exercises 6.5b on page 169, problems 2, 3, 6, and 8. Here the instructions state, state the obverse of each of the following propositions. Make sure that you use genuinely complementary terms. So beginning with number 2, you were given the proposition, some of the beans are cooked foods. And you had to find the obverse of this. Now, in order to find the obverse, you have to, number 1, find the opposite of the quality of the term. So this is an affirmative proposition, so therefore we have to change the quality to negative. So instead of saying are, we're going to have to say are not. Secondly, you have to find the complement of the predicate term. In this case, the predicate term is cooked foods, so you're going to have to find a complement, which could be uncooked foods. So the obverse of the first proposition would be some of the beans are not uncooked foods. So this is the obverse of some of the beans are cooked foods. You could have said non-cooked foods, but uncooked would be probably more grammatically sound way of saying it, or natural way, I should say. All of the dishes are washed things. Now, in order to find the obverse of this, we have to change the quality of the proposition. Again, this is an affirmative proposition, so we have to change it from all to no. And then we're also going to have to find the complement of the predicate term. And in this case, the predicate is washed things, so we're going to say unwashed things. So none of, or no dish in this, I say no dish in this group is an unwashed thing. You could have said none of the dishes, but the problem with saying none of the dishes is none is not one of our standard quantifiers. I think the book, its answer actually suggested saying none of the dishes. I said no dish, and you notice in parentheses I said in this group, because if you look at the initial statement, we're given all of the dishes. Technically, this is not exactly in standard form, because of the dishes is the subject term, but of the dishes is not, it doesn't name a class. But ordinarily, if you say all of the dishes, it seems like you're referring to a specific group of dishes. You're quantifying over a collection of dishes. You're not saying all dishes in the world, but you're saying all of the dishes, I don't know, in the kitchen or something like that. There's something implied here about the quantity of the dishes, or the group of dishes you're referring to. So that's why, I'm just, in the obverse, as I've stated it here, I'm just kind of crossing all the T's and dotting all the I's when I say no dish in this group is an unwashed thing. You could have just said no. If you'd said no dish is an unwashed thing, heck, if you'd even said none of the dishes is an unwashed thing, I wouldn't have complained too much about this particular one, just given the initial proposition you were given. But keep in mind, we do want to get in the habit of translating these into standard form. All right, some criminals are not insane. Well, again, in order to find the obverse of this, we have to change the quality of the proposition, and this is a negative, are not. So we have to change the are not to are, we'll change it from a negative to a positive, and then we have to change the complement and find the complement. So what's the complement of insane? You might say non-insane, which to say non-insane, you're just saying basically sane. So in other words, some criminals are sane. And you can see here that these are equivalent. Actually, when it comes to obverse, they're always equivalent. But some criminals are not insane is the same as saying some criminals are sane. So no sighting of a UFO is a thing that has been confirmed. So in this one, again, you have to change the quality, and the quality of this is negative, so we have to change it to affirmative, to positive. And so we're going to say all UFO sightings, or all sightings of UFOs, but I'm going to say, I think I said all UFO sightings. And then you have to change it, the predicate, and find the complement. So a thing that has been confirmed, you could just say an unconfirmed thing. So all sightings of UFOs, oh, I didn't, I thought I said all UFO sightings. You could, if you had said all UFO sightings, or if you had said all sightings of UFOs, those are equivalent. So if you'd said, anyways, I wrote all sightings of UFOs are unconfirmed things. You could have even said, or things that have been unconfirmed. I don't know if you want to use the similar tense of the initial proposition, but you could have also just said here something like all UFO sightings are unconfirmed things, or all sightings of UFOs are unconfirmed things. So here again we have the obverse. Now for the second part of your assignment, you are asked to do exercises 6.5C on page 173, problems 11 through 20. And here, what you were asked to do is you were asked to, for each of the proposition below, find the converse, obverse, or contrapositive as indicated in parentheses. And then determine whether the resulting proposition is equivalent or not. So here, basically, you are going to either have to find the obverse or the converse or the contrapositive, and then determine whether or not the resulting proposition is equivalent. So beginning with number 11 on page 173. So we're starting with number 11. You were given the proposition all non-S, that's supposed to be a line there, all non-S are non-P. And you were asked to find the obverse of this. And in order to find the obverse of this, what do? Well, first thing, you change the quality of the proposition. This is an affirmative proposition, so you're going to have to change it from I keep saying affirmative. You're going to have to change it from positive to negative, so you're going to have to say no, non-S is, and then you're going to have to find the complement of non-P. And what is the complement of non-P? Just P. And after we do that, we can then diagram this proposition. So, well, I say we can diagram it, but maybe you don't even need to do that. I don't know. If we want to find out whether or not these are equivalent. At this point, you should just know that whenever you take the obverse of something, it is going to be equivalent. The obverse proposition will be necessarily equivalent, whatever it happens to be. But just for fun, we're going to diagram some of these just so that we can get a little more practice doing so. All right. So let's suppose we were going to diagram the first proposition up here, and I'll just number it 1 and number this one 2. And we come down here, we're going to, I should label region 4 S, P, and we'll do 4 out here. All non-S are non-P. Well, first thing we have to do is we have to remember what all these different regions are. So I'm just going to say S is 1 and 2. Here, let me actually back up a little bit. S is 1 and 2. P is 2 and 3. Non-S is regions 3 and 4, and non-P are going to be 1 and 4. All right. So non-S 3 and 4 are non-P. Non-P is going to be 1 and 4. And if you recall how we do this, we isolate or identify the area of overlap. We scribble this out in the predicate. We're not concerned with it. And we're saying all of the non-S exist in non-P. So if they all exist in 4, how do we show that all of them are in 4? Well, we know that we have all here. We're going to be using shade. Remember, we use shade with all or no, X with some and some not. So we're going to be shading. And given that we're going to be shading, we know that shade means nothing. Shade, oh, I just realized you couldn't see some of this. So let me move my slide up here a little bit. Yeah, I'm going to have to, whoa, got a little crazy there. Sorry. All right. That's good enough. All right, so we know that shade is all or no, X is for some or some not, and we know that all of them are in 4. Well, shade means nothing, so if they are in 4, that means they're not in 3. So the way we would show this is we'd shade in 3. So let's come to no non-S is non-P. Well, non-S is region 3 and 4. Non-P is 1 and 4. Again, we circle where they are. Oh, I was like, something isn't right here. I said non-P. I'm sorry. I totally got off there. Non-S is 3 and 4. I haven't had enough coffee this morning. P, we're not dealing with non-P, we're dealing with P, is 2 and 3. We circle 3, and we scribble that out, and we're saying no. And we're saying nothing is in 3, so we come here, and we shade in 3. And so that's how we show, we diagram these two propositions. And the question is here, is the obverse equivalent? And the answer is yes, the obverse is equivalent. So like I said before, you could know that just from remembering that obverse is always equivalent. But you know, like I said, I want you to get into the habit of diagramming these, because you're not, I don't know, I guess if you just memorized, you know, that could work. But it's good to get in the habit of diagramming, just because when we start doing validity, it's going to become really important that you are familiar with how to diagram, and especially how to diagram complements. All right, so moving along, number 12. Some S are non-P. And here you were supposed to find the converse. Well, in order to find the converse, what you do is you basically just swap the subject and the predicate terms. And so the converse of this is going to be some non-P are S. And are these equivalent? Well, if we want to find whether or not they're equivalent, what we have to do is we have to diagram them. And you could just remember, like I said, when it comes to converse equivalence, you could just remember that the converse of an I-form proposition, it is equivalent. So that's one way. But if you forget that, this is where your trusty diagrams come in. Yay, diagrams. You know you love it. You know you love it. Don't act like you don't. So let's see. Do that. All right. And we do have to include this fourth region, because we are, whenever you see the word non appear in it, where you have a class complement named, that means you're going to have to draw the fourth region outside of the two circles. If you don't see non appear, you don't really have to worry about drawing the fourth region. But when you see non appear, then it becomes imperative that you do draw the fourth region. So, all right, so let's diagram these up here. I'm going to erase this line so we can be clear. Some S, and we know that S equals 1 and 2. P equals 2 and 3, non-S equals 3 and 4, and non-P equals 1 and 4. All right, so S is 1 and 2, non-P 1 and 4. And we identified that area, we crossed it out, and so we say sum, and we know that sum means whenever we see sum, we know we're going to use an X. All right, sum or sum not, we use X. So sum Rm1, so that's how we would do it. Well, what about down here? Non-P 1 and 4, and then S 1 and 2. We circle this, we scribble that out, circle that, sum, so we put an X here, and these are in fact equivalent. So the obverse of this statement, the converse, it is in fact equivalent. Well, let's move on and do number 13. Number 13, no, I didn't need to erase all of that, did I? Just got a little trigger happy. Number 13, no non-S is non-P. And for this one, you are asked to find the contrapositive. I'm not going to write that whole word out, but you were asked to find the contrapositive. Now, contrapositive, if you recall, it starts out a lot like the converse. You can think of it kind of like starting out because you're going to switch these around, but then after you switch them, you're also going to find the complements of it. You can do it the other way. You can find the complements and then switch them, but that's how it starts. So it's going to be no, and you switch non-P and non-S is non-S, and then you find the complements of each of them. So what's the complement of non-P? Well, the complement of non-P is just P. And what's the complement of non-S? Well, that's just S. So the contrapositive of no non-S is non-P is simply, no, sorry, I'm having a difficult time with this thing today. The contrapositive is simply no P is S. Now, are these equivalent? Well, let's diagram them and find out. So we're going to diagram the first sentence. Non-S is region 3 and 4. Non-P, 1 and 4. We circle the area of overlap. We scribble this out, and we're saying no. So what does that mean? When we say no to 4, we're saying no to 4. We shade in 4. All right. Well, down here, P. P is what? 2 and 3. P is 2 and 3. And S is 1 and 2. I can already tell you these aren't going to be equivalent even before I do the shading. But 2 down here and 2 right here. We scribble this out. Saying no, so we'd shade in right here. And so these are not equivalent. Sorry, I totally lost my train of thought for a second. These are not equivalent. So again, you could just remember that if you just remember that the contrapositive of an E form proposition is not equivalent. That could be the easiest way for you to do it, but you can also do the diagramming, and that will tell you if there's ever any doubt. So there are two ways to do it. I mean, like I said, you can memorize, or you can just learn how to do a diagram, and then you don't have to worry about remembering everything. Number 14. All right. All non-S are P. And for this one, you are asked to find the converse. All right. The converse, again, is really easy. You just draw the arrow to the wrong place. You just switch the subject and the predicate. So you're going to say all P are non-S. All right. And in order to diagram this one, in order to find out, are they equivalent, we could just look at the book and we could remember that A-form propositions, the converse, are never equivalent, but we're going to do better than that because we want to diagram it. So non-S is 3 and 4, and P is 2 and 3. And what we do is we circle the region of overlap. We scribble this one out because we don't care about that one. And then we say all of them are in 3. If they're all in 3, where are they not? All non-S are P. Where are they not? They're not in 4. They're not in 4 because they're all in P. All of the non-S are in P. All right, now come down here to P. To the second sentence. P is 2 and 3. Non-S is 1 and 2. We circle this, scribble that out. And we're saying all P are S. So they're all in 2. And if they're all in 2, where are they not? They're not in 3. Remember, we shade for all or no. So in this one, the two propositions are not logically equivalent. And like I said, we can determine that from just remembering that an A-form converse is never equivalent, or we can draw our trusty Venn diagrams. Yay for Venn diagrams. All right, number 15. All S are non-P. For this one, you are to find the contrapositive. And remember, when you're finding the contrapositive, what you do is you swap the subject and the predicate terms, and then you find the complement of each one of them. So if we're going to swap the subject and predicate terms, we're going to say all non-P are S, and then we have to find the complement of each. And so to find the complement, what's the complement of non-P? Simply P. What's the complement of S? Non-S. All right, and then we want to know, are these two statements equivalent? All S are non-P, all P are non-S. Well, you could just remember that an A-form contrapositive is always equivalent, or we could do what we're going to do is our trusty diagrams. 1 and 2 for S, non-P, we look down at the bottom, 1 and 4. Circle the area of overlap, disregard this one, and then we're saying all of the S are in region 1. They're all in region 1. And if they're not in region, if they're all in region 1, that means they're not any in 2. Okay, down here, P is region 2 and 3. Non-S is going to be region 3 and 4. Circle the area of overlap. Disregard this one. They're all in 3, which means they're nowhere in 2. So are these propositions logically equivalent? Yes, they are logically equivalent. So again, you can just remember that an A-form proposition, its contrapositive is always logically equivalent, or you can do our Venn diagrams. Some of you want to take the easy way out and just remember and not learn the Venn diagrams, but trust me, it's going to be important to learn them because, as I've said, we're going to start diagramming arguments after a little while, and it's going to be important that you know the process for doing it. Number 16. So in this one, some non-S are not non-P. And for this one, you were to find the contrapositive. Now, here to find the contrapositive, what you have to do is you swap the subject and the predicate terms. You're going to swap these. And so you're going to say some non-P are, man, that's poorly written, isn't it? Are not non-S. Then you find the class complement of each of the terms. So what's the complement of non-P? Simply P. What's the complement of non-S? Simply S. Okay, now let's erase this arrow so we can work a little more. So here we have our contrapositive. Some P are not S is the complement, is the contrapositive of some non-S or non-P. Now, are these logically equivalent? Well, again, you can just memorize that for an O-form proposition, it's contrapositive, always is, or we can do our trusty Venn diagrams. So, some of you right now probably thinking of doing a drinking game every time I say use trusty Venn diagram, but in any event, non-S is going to be region 3 and 4. Non-P is going to be 1 and 4. And what we do is we circle the region of overlap. We get rid of that. And we see that we have the word some here. So we know that we're going to be Xing, because remember we use X whenever we see the word some. And we're saying some are not. And so what we basically do is we look right here and we're saying are not in 4, so they must be in 3. If this had just said are, we'd be saying are in 4, but we're saying are not, so it's are not in 4, so therefore in 3. Now down here, P, region 2 and 3. S is region 1 and 2. Circle the region of overlap. Sorry, I was drawing a blank there for a second. Scribble this one out. And we're saying are not in 2. And if are not in 2, that means are in 3. So, are these the same diagram? Yes. And so these propositions are in fact logically equivalent. All right, number 17. So for number 17, you're given the following proposition. No non-S is P. And you were asked to find the converse of this. And so, again, for conversion, this one's the simplest one. You simply swap the subject and predicate term. So the converse for this is going to be no P is non-S. Now, again, you could just remember that when you're dealing with the converse of an E-form proposition, its converse is always equivalent, but get out your shot of whiskey because we're going to do a diagram in order to demonstrate this. So non-S is region 3 and 4. P is 2 and 3. We circle the area of overlap. We scribble that out. And we're saying no to 3. No to 3. Nothing is in 3. That's how we show that. Now we come down here to P. 2 and 3. Non-S. 3 and 4. We circle the region of overlap. Scribble that out. Saying no to 3. So we scribble this in right here. We shade that in. And are these identical? Yes. Therefore, these are, in fact, logically equivalent. Okay, number 18. Some non-S are non-P. Non-S are non-P. And for this one, you are asked to find the obverse. Now remember, with obverse, what we do is the first thing we do is we find the opposite of we find the quality of the proposition, whether it's positive or negative. I keep saying, I meant to say affirmative. I keep saying positive today. Affirmative or negative, and then we find the opposite of that. So we're going to say for this one, some non-S are not, because we're finding the opposite of that. And then we find the class complement of non-P. What's the class complement of non-P? Just P. All right. And so now what we want to do is we want to determine, are these logically equivalent? Some non-S are non-P, some non-S are not P. And you could just remember for obverse, it's always obverse is always logically equivalent. But let's diagram these just because we hadn't done any today. So non-S is 3 and 4, and non-P 1 and 4. We know we're going to be using an X because of that. We see some. So how do we do this? We put an X in 4 because we basically, you're saying R4. R-A-R-E, R-N-4, not R, but A-R-E 4. We're saying yes to 4. So now we come down here, some non-S. Non-S is region 3 and 4. P is going to be region 2 and 3. Circle the area of overlap. We know we're going to be using an X because of some, but notice we're saying R not. R not to 3. It's R not in 3. And if it's R not in 3, and the only thing we have left is 4, put an X in 4. So is the obverse of some non-S or non-P, is its obverse logically equivalent? Yes, sir. It most certainly is. Like I said, you can just memorize. I mean, obverse is actually the easiest. It's always equivalent with the obverse. But it's also important, as I've said multiple times, to know how to do the diagrams. Number 19, no S is non-P. No S is non-P, and we're asked to find the contrapositive. Well, how do we find the contrapositive? Well, first we switch the subject with the predicate term. So we're going to say no non-P is S, and then we find the class complement of each. What's the complement of non-P? It's just P. What's the complement of S? Non-S. And so this is the contrapositive. The contrapositive of no S is non-P is no P is non-S. Now, are these logically equivalent? Well, again, you could just remember that it is for an E-form proposition, the contrapositive is never equivalent, but we're going to diagram these. So S, region of S is 1 and 2. The region of non-P, 1 and 4. Circle where they overlap. Cross that out. And we're saying no to 1. Nothing in 1. So how do we show nothing is in 1? We shade in 1. Now we come down here, region P. Region P is 2 and 3. Non-S is going to be region 3 and 4. We circle where they overlap, which is region 3. Scribble that out. We're saying no to 3. No to 3. So we shade in over here. And we can see visually that these are not, in fact, logically equivalent. The diagrams are completely different. So the contrapositive of this statement was not logically equivalent, as is the case for the contrapositive of all E-form propositions. Last, but certainly not least, number 20, some S are not P. Some S are not P, and here we had to find the contrapositive of this. Now, in order to find the contrapositive, we switch the subject and the predicate terms. All right. In this case, the subject term is S, the predicate term is P, so we start off by saying some P are not S, and then we find the complement of each. What's the complement of P? non-P. What's the complement of S? Non-S. So I'm going to erase this so we have room to work. So we're going to diagram this. Region 1 and 2 is S. P is region 2 and 3. And we circle the area of overlap, which is region 2. And notice here we're saying R naught. R naught in 2. If it's R naught in 2, the only thing left is 1. We put an X because remember, when we see sum, think X. Now we come down here. Non-P. What region is non-P? That is 1 and 4. What region is non-S? That region is 3 and 4. So what do we do here? We circle the region where they overlap, which is regions 4. Cross that out. Saying R naught. R naught to 4. So it's R naught and 4. Where would it be? Well, the only thing left is 1. Put an X here. So is the contrapositive of some S or not P logically equivalent? Yes, the contrapositive is. As is the case with all contrapositives of O-form propositions. So hopefully by doing all these exercises, I know it's tedious going through and doing it over and over and over again, but truthfully that's the only way that you're really going to learn, and I hope you're getting a hang of this. If you're still struggling, please email me and we can see what we can do to resolve any difficulties you're having.